So here we have the janitor keyring with an auto backup module. So this is just a regular one here, and I have the USB dongle plugged in. Now the RF modules, you can literally just plug it out, plug it back in. So if you ever wanted to upgrade it, you could literally go online, get like one with a longer antenna, and if you ever decide to do that for whatever reason. But this says that it's good for 300 meters. I've tested it in different distances, and it's been working pretty fine. So we'll update a new password here. For instance, let's see, we're going to go for 48. Let's go. Right, because 48's not there, it'll just fill itself in. And there it is, it's green now that it has it. If you want to back up all the passwords, you just come over here like this. And it'll tell you that it's sending them over. Boom, boom, boom. Over here, you see it's working on it, 16. Now, these are taking longer because these are actually 255 character passwords. So, you can actually update the passwords to be anywhere between, 0, or I think I had a minimum of 8 characters. I have all the instructions on how you can basically update the characters for the boxes. So come over here. This is also a reset button just on the side if you want it for whatever reason. So let's see what the page looks like right now. Yep, so these are the text boxes if you want to update the color on it. Let's go ahead and push on one of these here. So you can go ahead and pass. Come over here. These are the text boxes. If you hit the middle one, right, it scrolls through the pages. Set the color. Hit it again. That's the text color with respect to that. All right, pretty simple. Now I'm going to get into the actual nuts and bolts of how I put these things together and why I made the specific decisions and choices, and basically like just understanding that it's all open. No point in asking you to put all your protected confidential information on this, but you can't understand or see the internals because I'm trying to hide it from you. I decided to leave it open. I'm probably just going to go ahead and clip in some of the information so you can see the water testing there. Just a time update to show you it's been a little less than an hour. Put it in front of a fan for it to dry. See, it's still a little bit of water under the screen, but files are still there. And see if we can't import those custom files. Oh wait, let's get back. Alright, so the files are obviously still there. And that shows how it was able to update the background text from what's originally there. All the passwords are still there. See, that's what happens when there's no password already created versus something that already has like a password. So for the most part, it's going to be open. I will close this bottom off, but we'll go ahead and take a look at the differences here. So here's the RF module. If you ever wanted to take it off for whatever reason, you just literally pull it out, plug in another one for whatever, if you didn't want it there. If you plug it out though, while you are updating the passwords, like if you wanted to update a new one, it might take a little bit longer just because it's going to be trying to send this information to here and it's not going to be there. Let's go ahead and see actually what that's like. We'll go for some glare there. We'll go for 10. We got going on here. So we got 10. I guess that's it. Wasn't very long, but then you see, right, didn't get the information. Also, really quick, most of the settings and functions shouldn't really be relevant for most cases, but they're just there for different situations when you need them. You come down here for system if you ever wanted to like put in your own special characters, and I showed that on another video. I'll link that. But now this is what it looks like. I changed it up a little bit so that way I can get a little bit more in there. That's just the test, right? The create, the import works the same as it used to. So you can just take this, plug it in anywhere where you have a USB port, any phone charger. But that's basically the difference here, right? I just added the module on there. So if it breaks, how hard is it to replace the screen? There you go, plug it right out. That's also where your SD card is saved. We're going to take a look at the internals here, right? So yes, it's kind of a little bit of a mess right now. Well, not right now, it's just the way it is, I guess, but I'll probably clean it up. It doesn't really matter, obviously. We have, this is the default USB, the one that you plug in for power. Now, if you were to accidentally mix these up, it doesn't really matter. It'll still go both ways. The only difference is that it just won't end up typing out. Basically, just the relay here is always keeping it connected here. Whenever it goes to send the signal to the relay, it switches the relay on. This is now connected. It talks to the board. Now, some more nerdy specifics about it here. You see a little thermistor there. That's just for temperature regulation. Go ahead and take a look. Oh, yes. Starting from here, right? So now, because You have these more sensitive components, right? Micro SD card that which requires like a stable 3.3 volts, as well as the fact that these little modules require more stable voltage. These are sensitive DC. Kept them further away from the actual relay because the relay is an analog and it switches a decent amount of power, and you want to keep your analog signal away from your DC signal. That's just typical knowledge. But more specifically with the design, right, taking advantage of the fact that over here, they're gonna make recommendations, and I still have the pins that I used to program it attached, but I'm gonna remove these when I put it together. But basically, attaching it directly bypassing the voltage regulator was important. They may not recommend it, but I don't necessarily follow recommendations. The reason why I decided to bypass the voltage regulator is because any USB port is going to provide me with a solid, stable 5 volts. Meanwhile, the voltage regulator, it works kind of analogous to, imagine if you had your car with a gas pedal and you replace the gas pedal with a button. And so now, like, let's say your car it only had the ability to drive 70 miles an hour. You hit the button at 70. And so how do you drive slower? You literally just start applying the brakes. And so if you have 10 volts coming in and you need 5 volts, what the voltage regulator does, it says, okay, don't worry about that extra 5 volts. I'll turn it into heat. Problem with that is, you generate too much heat basically as you start to pull more things, which is why having a screen that has its own voltage regulator helps take the load off that, bypassing it. And then also making sure that when the relay is switching and it's powered from its side of the board, having this having these traces that it has to travel through before it gets to that induction, it increases the amount of induction basically, and induction opposes changing current, which is beneficial, which is why I put the capacitor as close to it as I could. So basically this creates a more stable situation here, which overall, just different things that I consider. At the end of the day, it's pretty straightforward. It's just like this board talks to your computer, right? So basically it's like how do you get to the passwords? I mean, I don't know. You have to somehow connect to something. And like I think I said this before, the specifics of choosing a relay is because there's not going to be a scenario in which it can trigger itself without creating that audible sound. Right? You'll always hear it, so you'll know, because it just can't work any other way. Also, if it was to do so, it's only going to be connecting to this board, and this board is dumb. All it literally does is sit there waiting for an input, and then it outputs it. It waits for little signals like, hey, you're going to click now or you're not going to click, things of that nature, but it really doesn't have any information. And at the end of the day, these are microcontrollers, which was an intentional purchase. Microcontrollers, unlike a processor, right, like a computer, they're unable to download or install files. So from your computer, right, you open the wrong email, blah, 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 it can download malware and you may not even be aware. If they want to download malware into this, they actually have to erase all of the existing code, place all new code on it. And so that would be like reinstalling all of your Windows. And of course, it's faster here, but then even if you did, like I said, it's only this. Now the communication between this board and that board, it's one directional, right? It's basically this one talks to that one and it's not listening for information. So even if there was some way to get to all that, now what, it's sending information to something that's not listening. And then what is it going to do with that information? Exactly, so here it is, right? Like pretty simple, right? Just a relay to plug itself in and out, because this whole going back and forth, you make your program, then I make my program, and then you make a better program, and then it's just a never-ending game where they just keep ripping you off because, I'm like, no, none of that nonsense. Go ahead and make whatever program you want. I'm just going to plug it out, and stop telling people to plug it out as if you don't know that people can forget things. But that's what they make their business on. So plug it in and out. They want your passwords. They're going to have to come and get it. You want the passwords on this device, you have to come physically take it from me. It's like if I wrote it down on a sheet of paper, basically. It's just that this provides you the convenience of typing it in. So now what happens when you accidentally lose this? Well, it's just someone gets a free digital keyring. Unless they're going to somehow guess, you know what? Password number 48 must go to John Anderson's Bank of America account, and here's the username. So at the end of the day, it's like just pretty simple stuff. But the main considerations was the design of it here, right? You ever need to replace the relay? Don't want you wasting too much time. You just literally, I can't imagine why you would need to, right? Because this relays, they're rated for something like over a million. I think when I did the calculations, if you used it based on the measurements, right? And this is at 2 amps, which this doesn't use any amount of power like that. This might use or have to deal with maybe like a 1/10 of a percentage of that amount of power. But even then, I think it was something like 10 times a day, every single day of the week for like 27.5 years. As far as fall damage, I mean, like, I haven't been able to break it while it's inside the board. Now, if you drop it itself, you risk damaging it, but the board takes the brunt of the damage, right? And the board itself doesn't actually, these are designed so very hardy, which is the reason why, right? The reason why I chose to do this instead of making my own is because at the end of the day, one, there has been just so much energy and effort put into so many other brands making this for two reasons. They want this to be very, very useful, but they also want it to be something that people can learn on. The specific reason why it's important that someone can, to pick something that is also suitable for a learner is that when you make a mistake here, the real cost is that it destroys something, generally speaking, right? So I'll see a lot of times online, people are making complaints. They're like, this doesn't work, blah, blah, blah. Like with this, someone was complaining, this doesn't even work, right? Meanwhile, if you just look at something simple and you're like, well, the voltage regulator isn't capable of powering all of the stuff that you're trying to get it to power. And so now you're literally asking, so it's just random things. You plug in things the wrong way. And so in an effort to basically, have just a more user-friendly device, and because there's such a high amount of competition and there's just been out for years, the idea that I'm going to design something that's going to have this level of reliability to test it myself, like it's not even possible. And at the end of the day, this is not even the original brand. When you Google Arduino, which is the brand name, it costs twice as much. And the difference is that when China makes their product, right, people think, oh, Chinese products are bad. No, at the end of the day, they have better manufacturing techniques, but there's no legal requirements telling them that when they see, oh, someone did this cool update, I like it, it made their board better, I'm just going to copycat them. The problem is when you have a name brand or something like that, you're just stuck with your version. You want to change it based on what someone else did. Now you've got to try and go through their legal nonsense. Whereas in China, they're like, that's a cool little change you guys did. You moved this here, you did this like that. And so it's like the best of any world you want. You can get it here. It's half the price, and they don't have to design it, right? They have all of the years of testing. I mean, as far as I literally was surprised I couldn't break it. I literally shorted it out, plugged it in underwater several times. I washed it. At the end of the day, you know what happened to the board that I did all of that hard testing on? It's running my 3D printer right now. So the board, if you break that, if you break it, you're gonna have to come tell me exactly what you did so it'll blow my mind. I literally shorted these pins